Welcome to AI on AI, where we get practical and bold about how agentic systems actually learn. Today, we're dissecting Agent Lightning, a framework to train any AI agent with reinforcement learning while decoupling training from agent execution, which is a pretty big promise.
From a strategy lens, this decoupling flips the adoption curve. Enterprises can keep their existing agents in LangChain, an agent's SDK, or bespoke pipelines and add learning without rewrites. That's not a tooling tweak. That's an operating model change.
Technically, the trick is modeling agent execution as a Markov decision process. Each LLM invocation becomes an action, the input prompt is the observation, the evolving agent memory is the state, and the unified data interface extracts transitions, input, output, reward, without needing to flatten the whole workflow.
And systems-wise, the training agent disaggregation architecture matters. A Lightning server handles training and exposes an OpenAI-like API for inference during rollouts, while a lightweight Lightning client runs agent logic, tools, and observability, so you don't ship your emulators, databases, or peculiar toolchains into the training cluster.
Observability isn't a side quest here, it's the substrate. They use OpenTelemetry-style traces to capture spans for LLM calls, tool invocations, return codes, latencies, and attach rewards or intermediate signals. Then their AIR mechanism turns those signals into useful scalar feedback.
For business leaders, think of it as turning your live agent workflows, SQL, RAG, calculators, code tools, into a learning loop with governance. You can selectively optimize parts of a multi-agent workflow, measure uplift task by task, and keep your private data on your turf.
Let's ground this. Why does the transitions not concatenations idea unlock capability, both technically and strategically? Previous multi-turn RL often concatenated all turns into a huge sequence with token-level masks, fragile and slow. Masking breaks positional continuity assumptions like rope, complicates kernels, and magnifies context length, while transitions let you train on each call's natural input-output, so you keep the LLM's steady footing and shorten sequences dramatically.
Right. And because the client runs the agent, you avoid entangling rollout with training kernels. You can run 100 workers across nodes, each executing tools locally with two-level parallelism, within a machine and across machines, while the server does batched generation and learning with a clean API boundary.
Strategically, that lowers integration risk. The largest cost in pilots is usually orchestration friction, not GPU hours. If your training stack can be swapped without touching your agent logic, you de-risk upgrades and vendor pivots.
Lightning RL, the hierarchical bit, how does it actually use single-turn RL algorithms for multi-turn agents? Each LLM call is one high-level action. Lightning RL assigns credit from the episode return down to each action, initially uniform if only a terminal reward exists, then uses a single-turn algorithm like PEO or PPO to distribute token-level advantage. Importantly, for GARPO, you group samples by task to estimate advantage via reward normalization per prompt.
And when you do have intermediate signals, say tool success flags, SQL execution status, or format compliance, AIR injects those as step-level rewards, so credit assignment isn't blind. Think of AIR as reward mining from telemetry, not annotation.
That unlocks business KPIs beyond pass-fail accuracy. Tool success rate, retrieval coverage, SQL execution success before final answer. These become levers for both training and operations. Several teams see double-digit percentage gains on these intermediate metrics before final accuracy catches up.
Let's do our first deep dive on credit assignment. What's elegant here, and where are the landmines? Elegance. Transitions sidestep the concatenation mess and allow per-call observation construction. Maybe a templated prompt, maybe a short state summary, maybe role instructions for a single model playing multiple roles. Then GRPO groups by task, so advantage estimation is statistically stable even when the call contexts differ. Landmines. If you misspecify rewards, the uniform action credit can reinforce the wrong step.
That's where AIR shines. Map tool-level traces to reward heuristics. Plus 0.2 if SQL compiles, plus 0.3 if execution returns non-empty rows, minus 0.3 on exception. Even noisy shaping accelerates learning by reducing horizon. A A practical heuristic is don't let terminal-only rewards exceed 70% of the episode signal unless your tasks are trivial.
Implementation detail. Because each transition is independent for training, you avoid the class of bugs where long sequences trigger context window paging or weird attention masks, and you can do gradient accumulation cleanly. Also, failures in one call don't poison the whole batch.
Business case number 1, text to SQL with LangChain and Spider. What actually moved and why?
The workflow had a SQL writer, a checker, and a rewriter answerer. Lightning tuned 2 of the 3. Teams typically report a steady climb in final answer accuracy and, crucially, SQL execution success rate. Think 15 to 25% improvement in SQL validity across a few training cycles. And when the checker nudges the rewriter, we see fewer loops and faster convergence to correct queries.
From a P&L perspective, that changes the attrition in your human-in-the-loop queue. If 20% fewer tickets escalate due to broken SQL, your throughput and SLA hit rates jump. The second-order effect is schema onboarding. New databases stop being a cliff because the agent self-updates against your private schemas.
Tactically, the uniform credit assignment works because SQL compilation and execution produce clean binary outcomes, which AIR translates into robust intermediate rewards. You get optimization pressure before the final answer. This is a textbook case of reward sparsity reduction. Case 2, RAG over Wikipedia scale with Agents SDK. What did we learn from the multi-hop dynamics?
Multi-hop QA often suffers from retrieval drift, queries that are semantically near but logically useless. The training reward combined word-level F1 on the final answer with a small format bonus, so the agent learned to keep its think, query, answer structure while improving semantic specificity of queries.
Systemically, the large index means latency spikes. The disaggregated runtime lets you deploy retrievers local to the client, not the trainer, so you don't drag the index into the GPU cluster. Rollout throughput increases, variance decreases, and the training loop sees steadier gradients.
Business-wise, teams see retrieval coverage improvements, more top K hits containing gold facts, which is an early leading indicator. Even a 10 to 15% bump in retrieval coverage over 4 to 6 weeks translates into higher correct answer rates downstream without expanding context windows.
Case 3, Math QA with tool use via AutoGen. What's the nuance with calculator tools? Tool invocation is a great stress test for step-level credit. The agent must learn when to call, with what arguments, and how to incorporate returns. AIR can mark syntactically valid tool call, execution success, and numeric consistency checks as rewards. A subtlety is penalizing gratuitous tool calls, so you add a small negative reward per call unless it reduces final error.
One practical tactic is guardrail parsers at the client runtime that validate tool call JSON and feed pass-fail into rewards. We've seen increased tool call precision and reduced hallucinated arithmetic steps over training.
And from operations, this reduces back and forths in support workflows, fewer edge case calculation errors, clearer audit trails for how the answer was derived, and better explainability for compliance reviews.
I want a contrarian view. What's the risk nobody's talking about?
Everyone fixates on training efficiency, but the real bottleneck is rollout orchestration. If your environments, tools, or network are flaky, your throughput collapses. The fastest GPU is an idle one, and the disaggregated design only pays off if your client-side reliability is engineered like production.
I'll add a second contrarian point. Uniform action credit is simple, but can cement bad habits in early steps. If the first query is consistently off, later steps can't rescue the episode. A learned high-level value function for action-level returns could improve sensitivity to early decisions. Hierarchical critics are underexplored here.
One more, governance. If you attach AIR rewards to operational signals, you might inadvertently optimize for system idiosyncrasies, like preferring faster but lower quality retrievers. You need metric governance so the reward doesn't drift from business value.
Let's pivot to multi-agent versus single model with roles. How does Lightning handle both? For single model, multi-role agents, each call is a transition with a role-specific prompt: searcher role, answerer role, planner role. For multi-LLM agents, you can optimize each as its own MDP independently. For deep coupling, you'd want multi-agent RL, but practically, independent transitions with shared datasets already yield strong coordination, especially when AIR signals interlink the steps.
And the transition-level dataset enables selective optimization. Only include the rewriter transitions if you're happy with the checker. You don't need contorted masks or special concatenation just to target a subset of behavior.
Technical deep dive number 2. How do advantage estimation and grouping actually work across dynamic contexts? In GRPO-style training, the advantage per token is the response reward normalized against a group of responses for the same prompt. Lightning groups by task, so even if step contexts differ per execution, all transitions from task X form a group for statistics. This keeps the baseline coherent without a separate critic, and you can batch transitions regardless of varying lengths because you're not packing whole episodes.
That grouping meshes well with the server's inventory dispatch. The server tracks tasks, hands them to clients with the model endpoint, collects transitions and rewards, then ships them to the trainer in batches. The trainer treats them as regular single-turn samples with attached advantages, no exotic data loader.
Technical deep dive number 3. How does the observability to reward pipeline avoid brittleness?
3 practices. First, tiered reward schemas. Primary terminal reward, secondary structural or tool success signals, tertiary hygiene signals like format compliance. Second, stability checks. Build dashboards to ensure intermediate rewards correlate with terminal outcomes. Third, back-off policies. If telemetry is missing, don't invent rewards, just mark as null and fall back to terminal-only updates.
And avoid reward hacking by including KL or entropy regularization. Keep the policy from drifting into brittle hacks. Even in GRPO, add KL to a reference model so exploration doesn't break format or trust boundaries. Speaking of trust boundaries, what does governance look like with this architecture?
Policy. Define what's optimizable. Components of interest, maybe prompts are in scope. SQL generation is in scope, but PII handling prompts aren't. Metrics. Adopt layered KPIs, task success, tool precision recall, hallucination rate, escalation rate. Process. Gated promotion where the Lightning server's model endpoint graduates to staging, then production after holdout set evaluation.
In regulated contexts, on-prem Lightning clients are key. They let you run private tools and data locally, ship only hashed or redacted telemetry to the trainer, and still participate in the learning loop. That respects data residency and reduces vendor lock-in.
Let's explore emerging markets. What changes when infra is variable or APIs aren't standardized?
2 realities: tool heterogeneity and network volatility. Decoupled clients can collocate with local tools, reducing latency and outages. AIR can treat network timeouts and retries as negative rewards, teaching agents to prefer robust tools in that region. And because observability is standardized, you can compare tool ecosystems across markets and adapt policies per region.
Also, the client's pooling of shared services, like heavy emulators or retrieval indices, avoids per-worker cold starts. That's huge where compute elasticity is limited. Your rollout throughput becomes predictable instead of spiky.
Where should teams start? What's a crisp adoption playbook?
4 steps. 1. Instrument your agent with the Lightning client and define components of interest. 2. Specify terminal success metrics and a minimal AIR schema, 1 or 2 intermediate signals. 3. Run shadow training with holdout evaluations weekly, looking for double-digit gains on intermediate KPIs. 4. Promote in slices. Optimize one agent role, run A/B, then expand.
And keep reward scopes tight. Measure what you can trust is the mantra. It's better to have 2 reliable intermediate rewards than 10 noisy ones.
How about offline data? Can you bootstrap without live rollouts? Yes, because transitions are the core unit, you can replay historical traces as a dataset. If you have terminal labels or can reconstruct them, say pass-fail from ticket resolution, you can run offline RL-ish policy gradient with reinforced ++ baselines. then fine-tune online with AIR for stability.
Caveat: logged datasets may have tool versions or prompts that differ. The client's meta captures component versions, so you can filter or stratify in training to avoid mixing incompatible contexts.
Let's interrogate the masking is dead claim. Is there any case where concatenation wins? Rarely, but if your agent logic is strictly linear with tiny contexts and you need cross-step attention at train time, concatenation can encode dependencies better. However, most industrial agents build observations that already summarize prior steps, so transition-based training aligns with production behavior and scales better.
Plus, concatenation masks tend to ossify bespoke code that breaks on the next agent refactor. Transitions are more future-proof because they don't assume a specific orchestration topology.
What about the performance frontier? How do we keep pushing beyond value-free methods? Two directions. Learn a high-level value function to assign non-uniform credit to actions, especially early queries in RAG or first drafts in coding. And explore off-policy algorithms to reuse more data. Importance sampling with robust baselines can stabilize updates from logged traces.
On systems, disaggregate further. Separate trainer, inference engine, and agent runtime entirely. Scale rollouts via elastic inference pools while keeping agents local. Think of the server as a coordinator of gradients and the clients as elastic, fault-tolerant generators of trajectories.
Can we talk failure modes? What breaks and how do we recover?
3 common failures. Runaway retries on flaky tools, mitigate with timeouts and negative rewards. Prompt bloat, solve with structured prompts and strict parsers for tool calls. Reward drift, monitor the correlation between intermediate and terminal rewards weekly. If it drops, reweight or prune that AIR signal.
And an organizational failure. Treating this as a one-off model project. It's a product capability. Assign ownership for reward design, telemetry, health, and KPI governance. When those roles exist, teams sustain improvement beyond the pilot.
I want each of you to drop one heuristic leaders can use tomorrow.
Optimize at the boundaries, reward what hands off between agent roles. Improving the seams often creates the fastest end-to-end gains.
Reward sparsity kills. Add at least one intermediate reward per 2 LLM calls to shorten horizons.
Throughput first. Measure rollouts per minute end-to-end, not just tokens per second. The trainer can only learn from what it sees.
Logs are the ground truth. If it's not in a trace, it won't become a reward. Invest in observability before clever algorithms.
Localize robustness. Train per-region tool preferences using AIR on reliability, not just accuracy. Resilience outperforms raw speed in volatile environments.
Before we close, any second or third order effects we should be wary of or excited about. Second order. The unified interface turns agents into data engines. You'll discover new supervision primitives like schema deltas, API rate limit events becoming training signals. The data is often more transformative than the algorithmic tweak.
Third order. Once disaggregated, you can run federated training where clients keep rewards and traces locally and only ship gradients or summaries. That dovetails with privacy regimes and lets global models benefit from local quirks without moving raw data.
And strategically, this blurs the line between prompt ops and model ops. Components of interest can include prompt templates. You'll A/B test prompt variants under RL pressure and retire hand tuning faster. That accelerates learning cycles across product lines.
Last lightning round. What's one improvement you'd ship into Lightning RL next quarter? A hierarchical critic that estimates per action value given state summaries, better early step credit.
A serverless reward service in the client runtime, hot swappable reward functions with isolation and autoscaling.
Built-in reward drift detectors that flag when intermediate signals decouple from business outcomes.
A governance dashboard mapping components of interest to KPIs with safe rollout controls per region.
I love it. Today we covered how Agent Lightning reframes agent training with transitions over concatenations, hierarchical RL that rides on single-turn algorithms, and a decoupled architecture that respects your tools and data with observability as the reward engine.
If you remember one thing, this approach lets you keep your agents and add learning without breaking the house. Incremental change, compounding returns.
And for technologists, elegant credit assignment, robust batching, fewer hacks, cleaner training loops that match deployment reality.
For platform teams, treat rollout infrastructure as a product. Reliability is capability.
For rewards folks, small, honest signals beat elaborate but noisy labels. Start simple, iterate fast.
And for global operators, use AIR to optimize for the realities of your markets. Resilience is a feature, not an afterthought.
That's a wrap. Thanks for joining us on AI on AI. May your traces be rich, your rewards aligned, and your agents, well, lightning fast in learning. See you next time. Before we truly sign off, let's stitch an end-to-end recap. What Agent Lightning brings is a clean split between how agents run and how models learn, a unified transition-level data interface born from an MDP lens, and Lightning RL's hierarchical credit assignment that reuses robust single-turn RL, PPO Reinforce Plus, while AIR converts observability signals into intermediate rewards so agents can learn from the real work they do. Technically, the big three are: 1. Transitions over concatenations, which preserves positional coherence, shrinks context, and removes masking complexity. 2. Credit assignment that pushes episode returns down to actions and then down to tokens via standard single-turn RL, grouping advantages per task for stable stats. And 3. AIR reward shaping from telemetry, tool return codes, SQL compile execute signals, format compliance, plus a KL tether to a reference model to avoid drift.
On systems, the training agent disaggregation pays off. A Lightning server runs training and serves an OpenAI-like endpoint. Lightning clients execute agents and tools in their own environments, with two-level parallelism and inventory-style dispatch. So rollout throughput is steady, failures are isolated, and you never have to drag databases, emulators, or weird tool chains into your GPU cluster.
Observability becomes a reward engine. OpenTelemetry traces become structured spans you can score. Then tiered rewards, terminal, tool success, hygiene, stabilize learning. Couple that with drift guards and null-safe fallbacks when telemetry is missing, and your reward pipeline stays honest rather than clever.
Strategically, this lets enterprises keep their current agents, LangChain, Agents SDK, AutoGen, bespoke code, and layer learning in place. We saw steady lifts in SQL execution validity, RAG retrieval coverage, and tool call precision, which translate into faster resolution times, fewer escalations, and easier onboarding of new schemas and tools across regions.
Highlights from the field. 3 case patterns stood out. Text to SQL, where binary execution signals make AIR particularly potent. Multi-hop RAG at Wikipedia scale, where structure and F1 rewards curb retrieval drift. And math tool use, where guardrail parsers plus small penalties for gratuitous calls improved tool precision and reduced hallucinated arithmetic.
The business playbook is simple but powerful. Define components of interest so you optimize just the parts that matter. Instrument 2 trustworthy intermediate rewards per workflow. Run shadow training with weekly holdout checks. And promote by slices, role by role, region by region, under KPI governance that tracks task success, tool precision recall, hallucination, and escalation rates.
Forward-looking, the next technical frontier is a learned high-level critic for per-action value, especially for early-step sensitivity in RAG and code workflows. Plus off-policy reuse of log traces to compound learning without exploding rollout budgets. The math is ready, the data plumbing is now in place.
And the systems frontier is deeper disaggregation. Trainer, inference pool, and agent runtime as independent services, plus serverless reward services, so teams can hot swap reward logic safely without touching training loops or agent code.
One cautionary insight: don't overfit to operational quirks. Correlate intermediate rewards with terminal outcomes weekly and reweight when they decouple. Measure what you can trust beats measure everything every time.
For global operators, resilience is a feature. Localized tool choices via AIR on reliability, not just accuracy. In emerging markets, timeouts and flaky networks carry negative rewards on purpose. Policies learn to prefer robust paths that keep SLAs intact.
Key innovations in one breath. MDP framing with a unified transition interface, Lightning RL's hierarchical credit assignment layered on single-turn algorithms, AIR for turning traces into learning signals, and the training agent disaggregation that makes any agent trainable with almost zero code change. The second and third order effects are big. Your agents become data engines, governance becomes first class, and federated or region-aware learning becomes realistic. Final takeaway: keep your agents, add learning, and let observability be the bridge. Start with 2 honest intermediate rewards. Optimize the seams between roles and treat rollout reliability as product. You'll see compounding improvements without rebuilding your stack. Thanks for staying with us. May your transitions be clean, your rewards aligned, and your training loops frictionless. This is AI on AI, signing off until next time.